Hello, everyone. Welcome to Can.Do.So. This is Ready, and today we're going to learn how to run multiple linear regression with R. So we are we will cover basics of multiple linear regression and run multiple linear regression with R and interpret the outcome of the regression and briefly cover the model specification. So let's get started. We use the library. We load the tidyverse. So multiple linear regression is an extension of simple linear regression. We have covered the in previous course that simple linear regression is like this. Just you can see that's just there's only one simple because there's only one predictor, so that's why we call it simple. And this is error term, and this is intercept. This is called a predictor or independent variable, and this is dependent variable or called the estimate. Okay. So this is a example of the simple linear regression. Miles per gallon can be predicted by the weight of the car. We can imagine that the heavier the car and the less they can run, they can go. So why we need multiple linear regression? In real world, it is rare that one outcome is only affected by one factor. In other words, an outcome normally is the outcome of many different factors. For example, the miles per gallon of a car may be mainly affected by its weight, but it is also affected by other factors such as the number of cylinders and horsepower, or the transmission model, which means it's a automatic car or manual car. Therefore, so we need to consider more than one predictor variables in the model. So to run multiple linear regression, it's also very easy. We just add more predictors to the model. For example, here we use 3 predictors. If we just cover this one, then it's a simple linear regression, but now we added x2, x3, and so on. This is a error term. So for example, we also use miles per gallon, which is maybe based on its weight, horsepower, and the rear axle ratio, and the transmission model, automatic or manual. So the model is expressed as follows. Yeah, here we have 4 predictors. We also use the LM function, which is to run multiple linear regression. LM is a linear model, so here is multiple, but it's still, although it's a multiple factors, but it's still a linear regression. We will cover the nonlinear regression model in the future courses. So as AM is the yes, let's go to the because so AM is, although it's number 10, but actually it means automatic or manual. It's two types of transmission model. So we convert it to factors. And this is dependent variable miles per gallon and weight, horsepower, draft, and transmission. So we use the summary to show the model outcome. Oh, sorry, we need to library the, yes. So we got the model, how to understand the outcome first. Here, the first one tells us the model, what's the model, and the dependent variable and independent variable, and the data, and the function. It's a linear model, and residuals. It's a summary of residuals. Normally, a residual, if it's a good model, the residuals should be normally distributed around 0. So this one is, we can say it's around -3 to 5, around 0. And median is not exactly 0, but close. So intercept is a constant part, and this is weight. So the first one is factors or variables, independent variables. Here we have 4: weight, horsepower, drag, and transmission. Because this is transmission is expressed by 0 and 1, and 0 is automatic and 1 is manual. So in this case, which means manual compared to automatic, it's if it's a manual, so it will increase the miles per gallon. And this one is estimated coefficients, and this is a standard error of the coefficients, and this t value. We know that t value and p value, are the different side of the same thing. So if t value is greater, the p value will be smaller. I mean the absolute value, which means the further away from the 0, then the p value will be fewer, and the close to 0, then the p value will be bigger. Like this two, the t value is few, so the p value is big, and this p value is very big, and so the p value is very small. So normally the star means significant. Here, 3 stars, it's close to 0, and 2 stars is less than 0.001. 2 star, and 1 star is less than 1%, and the small dot is less than 5%. So in this case, the weight and horsepower is significant because it's quite small, but the drag and transmission is not significant because it's much bigger than 5% level of significant. Okay, also there's this residual standard error is 2.56 on 27 degrees of freedom, and adjusted R square 81.2%, which means in this case, about 82% has been explained by this model. So it's quite big, quite good. And also the F statistics is 36. It's quite big. So the PY is very small, very close to zero. In this case, which means at least one of these is significant. One of the four predictors is significant. Here we have two. So if all of these predictors are not significant, so then the p-value will not significant as well either. So we can see that the WT is minus 2.72. Yes, it's fit our expectations, because the heavier the car, the fewer distance they can go. So in this case, if the car is 1,000 pounds weight heavier than they will have 2.72 miles fewer per gallon. And let's take a look at horsepower. The horsepower is significant.
Okay, I found this on the web for let's take a look at the horsepower. Horsepower is
excuse me. And HP, which means if the car increase 100 horsepower, then the car will decrease 5.6 miles per gallon. And we can see that these two variables are not significant. So although this is a positive effect, but it's not significant. Okay, the model specification. First, we just briefly explain this issue, because in the model, which one should be included and which one should not be included. We have used our theory, use our knowledge about the question we are trying to answer. So this is not the this is very important. So to include which variables or exclude which variables, it's important, and it's very difficult to some extent. To run regression is very easy. You just input the data and use R to run it. You can get the outcome almost by a click. However, it's not very easy. It's not easy to decide which variables should be included in the model. So it is not the it is not the purpose of this course, because that should be based on your theory, your questions, and your knowledge about your research background. And but we have to be clear that we can't just first run the regression to try multiple to try multiple variables. For example, if we find this is not very good, we use a different one. For example, we change the drat to qsig, and to say if it's better. It looks better because this one is significant. If we want to test if we want to prove that the transmission mode is also important to miles per gallon, so you might want to use this one instead of this one. But that's not a good idea because you are just trying and to get a you're just trying many different variables, and in order to get a outcome you expected. That's not doing research. That's just try by luck. We will not recommend that. So we have to use our theory to establish a model with a strong academic and theory support. So we cannot tell you in this course, we cannot tell you what kind of model, what kind of variables you should include, and what kind of variables you should not, you should exclude. But we can check once you have selected your variables, we can check with our skills to find if this model is good or bad, is a good fit or a bad model. We can do that, and this will be covered in the future courses. Okay, that's all for today's course, and thank you for watching, and please leave a message below to raise your questions or offer your suggestions. And if you like it, please share it and like it and subscribe to the channel, and see you next time.